Okay. So we start right here. Complex numbers. Plus, square root of -1 is plus or minus I, either one. Okay, positive or negative I is the square root of -1. That means that if you square I, you get -1. That is, again, by definition. I can't give you a proof of that. We accept that to be true by stating that, again, x squared plus 1 equals 0 is going to have two solutions, okay? Now, here's the other part I want you to see. So we've now said that there's imaginary parts. You can't point to those imaginary parts on the number line. We will later on graph. Oh, I will teach you how to graph imaginary numbers or complex numbers second semester, and I'll even teach you how to do this. You know what the square root of -1 is equal to I, right? What's the square root of I? Huh. That's a good question. Every time you find something else out, you have another question. In fact, I will teach you, second semester, how to find the fifth root of 8 minus 3i. That looks absolutely ridiculous, but we can do that. It's so cool. It's so cool, but we can do that. The second semester. So, every number can be written in complex form, a plus bi, where this is the real part of the number and this is the imaginary part. And those are complex numbers. There's a course I took in college called Real Analysis. That just has to do with mathematics on the real number line. You can also take a course called Complex Analysis. So, I'm going to teach you how to add, subtract, multiply, divide, and use exponents with imaginary numbers and complex numbers. Very simple. 4 plus 3i minus 6 plus 8i. I distribute the negative. So I have two complex numbers. I want to subtract them, distribute the negative, and then combine the like terms. So 4 and -6 make, and 3i and 8i make, and that's it. That's the real part. That's the imaginary part. -2 is the real, 11 is the imaginary. Yep. So Carissa D asks a very good question. I'm just going to write this up here. You don't have to write this down. You guys have seen the number 3 for many, many years. The real part of the number 3 is 3. What's the imaginary part? 0. 2i is an imaginary number. 2 is the imaginary part. What's the real part? 0. 4 minus 5i is a complex number. What's the real part? 4. What's the imaginary part? -5. So you see, these numbers before, they have an imaginary part or real part. It's just 0. We just don't talk about it. So here you go. So we distribute the negative through. We have 1, 3, and -6. That makes -2. -i, and 5i make 3i. So the real part is -2. The imaginary part is 3. Yes. No. You have to write it as a plus bi. Very good question. The I must be on the end. The real part must be at the beginning. Must. If you don't do it, you cut your finger off. And give it to Miss Nelson. Because she's weird like that. So, you know how to add them, you know how to subtract them, right? Let's multiply them. 4i times 7i. What's 4 times 7? 28. I times I is I squared. What is I squared? -1, and so 28 times -1 is -28. Very good. Beautiful. 3i times negative 8i. What's 3 times negative 8? Negative 24 times I squared. I squared is negative 1, and so you have negative 24 times negative 1 is positive 24. So sometimes people say, well, if it has an I in it, and you're multiplying them together, the result's always going to be negative. Well, no, not necessarily. Here you get a 24. It depends on what the value of the rest of the numbers are as well. This one, you're going to end up with 3 negatives. Question? No, but the assignment today is all the odds. And if you simply write down the answers in the back of the book, I will watch your homework assignments like a hawk for the rest of the year. So just make sure that you do it. If you can tell right, like I can look at this and I can see that the answer is 24. That's fine. Negative 2i times negative I. That would be a positive 2 times I squared. And what's positive 2i squared? Negative 2. So you can see I took a step out now in that last one. That's fine. I times negative I times negative 2i. 6 times negative 1 times negative 2 is positive 12. And how many i's do you have? I to the third. Well, you can rewrite that as 12i squared times I, right? Same thing? Everyone's okay with that? What's 12i squared? And negative 12 times I is negative 12i. So there the i's did not go away. You ended up with an I in the end result. Question. Well, do you know what I to the third is? That's why I did it. I wrote it like that so you could see that that's going to give you a negative 1. So you'd have negative 12i. Yes. You can't write 12i to the third. That's not simplified. If you could take a negative 1 out because I squared is negative 1, you need to do that. Bryn. What's that? No. I is not negative 1. I is the square root of negative 1. So we cannot simply replace this with a negative 1. The I squared, yes, that becomes a negative 1, which shows up right there. Negative I to the third. Very good. You have negative I squared times I, correct? What's I squared? Negative 1 times a negative is positive 1. So positive 1 times I is just I. I to the 120. Question. Ooh. Good question, Emily. Let's investigate that a little bit more. Those are different. Here, I'm doing what you just suggested. I'm squaring the negative. This problem is not squaring the negative. I squared and then multiply by a negative. Exactly. That's the difference. Everybody see that? Okay, let's try a real problem. Those were child's play. This one's more interesting. I to the 122nd. What? You think negative 1. Haley, do you concur? Let's see if they're right. What's I to the 1? I. What's I squared? I to the third would be, and we've done this already, I to the third would be I squared, or negative 1 times another I, correct? Which would be negative I. I to the fourth would be I squared times I squared. What's I squared times I squared? 1. I to the fifth. I to the fifth would be I times I to the fourth. What is I times 1? That's the same as that, isn't it? I to the fifth is the same as I to the first. So what's going to happen? It's a cycle. It's going to repeat itself over and over and over and over again. So this will be I to the sixth, I to the seventh, I to the eighth. Well, I don't want to write them all out. So what do you notice about this right here? Divisible by? Cycles through by 4, so divisible by 4. What is a number close to 122 that's divisible by 4? 120. So I to the 120th is the same as I to the 4th. So that means I to the 121 is going to be the same as I to the 1st. And I to the 122 is going to be the same as I to the 2nd. So, I to the 122nd, negative 1. Question. This is the work. This is a very convincing argument. This is the cycle that you show through. You know, so this would be I the 119th, this would be I the 118th, I the 117th. You don't have to write them all out, but it's that idea that we know what's happening here. We see the pattern. If it's divisible by 4, it goes on the bottom. Question. So the answer is I to the 122nd is negative 1. Very good. And Miss Carissa D. Negative I? Watch. Right? What's I times I? Which is? Negative 1, right? Times I, negative I. That? Yes? Any other questions about that? All right, we flip to the back side. You guys are rolling, but you're a super smart class. The best of the best. 7 problems on the back side. We're going to distribute through here. We've got a 3i on the outside. We just bring it right through. What's 3i times 2? 6i. 3i times negative 5i. Very good. Negative 15i squared. What is negative 15i squared? Positive 15. You write the real part first. You write the imaginary part second. All of the time. Because we're going to use that later on in trigonometry. 2 minus I times 2 plus I. 2 times 2 is 4. 2 times 2i, or 2 times I is plus 2i, and negative I times 2 is negative 2i. So Scott saw that those are going to cancel, right? They're just going to go away. And what do you have at the end? Minus I squared. So again, what happens in the middle? Go away. And you get 4. What's negative I squared? Positive 1. You get 5. 2 minus I times 2 plus I happens to be 5. Isn't that weird? So, if you take 5 and divide it by 2 minus I, what do you get? You get 2 plus I. Isn't that kind of weird? But it's the way it works. Okay. 6 plus I, 3 minus 7i. Let's do this one. We got to multiply everything through. 6 times 3, 18. 6 times negative 7i. Negative 42i. I times 3. plus 3i, and I times negative 7i is negative 7i squared. Let's just do our imaginary parts right away. You have negative 42i and positive 3i. Those make negative 39i. And what is 18 plus a negative 7i squared? 25. Because negative 7i squared will be positive 7 plus 18, 25. I like them apples. Kyle likes it. He says, I do imaginary numbers all day long. Could be an engineer, you gotta know. Did you know that about Kyle? He's gonna be a mechanical engineer? Or did you say civil engineer? You didn't know that? I thought you said that sometime. Was that your good friend Julian? No. I could have sworn you told me you were going to do mechanical engineering. Computer engineering? I was close. If you count engineering as being close. Alright. 4 divided by I. You can't have an imaginary part in a denominator. You got to express it as a complex number. This doesn't work, and we have a way to get around it. It's very simple. We multiply the top and bottom by I. So what's I times I? Negative 1, and the top gives me... What's 4i divided by negative 1? Negative 4i. Question. No, the reason why we don't like I in the denominator is because we want to write everything in complex form. That's really what it comes down to. Complex form allows us to work with it. Like, for example, before I said that someday I'll teach you how to do the 5th root of 8 plus 3i or something like that. Okay, we really want it in complex form. Okay, and 4 over I just does not work for us to do that. Okay. All right. We try another one. Negative 3 over 2i. Same thing. We're going to multiply the top by I and the bottom by I. What do you get on the top? Negative 3i. Don't need to do the 2. Just got multiplied by I. What's 2i times I? Negative 2. 2i squared, which is negative 2. I don't leave it like that. What's negative 3 over negative 2? 3 halves, and I put the I on the end. Always put the I on the end. Always, always, always. Sini. You know what? If your mom watches the videos, I should make it sound like it. Sini, wake up! Sini, leave Carissa alone, now! Do I need to send you to the office? Oh. Alright, this one's different. What makes this one more difficult? Oh, that's a good idea. I never thought about cutting your finger off here, but, you know, that's how fear always works, I guess, huh? You could threaten people. You know, the reason why this is difficult is if you multiply the bottom by I, then you get I minus 1. Because 1 times I is I times I is negative 1. So did the I go away in the denominator? It did not. So look at this. Look at back to a problem that we learned about earlier. 2 minus I times 2 plus I. Do you see how the i's went away there? So there's a special complex number we can multiply by to make the I go away in the denominator. Does anybody see what it is? 1 minus I would work in this scenario, but we want to do I minus 1. top and bottom. Do you know what I minus 1 is called compared to I plus 1? It starts with a C. Rhymes with conjugate. Conjugate, very good. Just like in Spanish, if you change the ending, it changes the meaning of the verb, right? And same thing here, if you change the ending, instead of a plus, it's a minus, it's going to help you change the problem. So conjugate is a useful piece. Let's multiply it out. What's 3 times I? 3i. 3 times negative 1? Negative 3. Over. Look at the bottom. You know the middles are going to go away. So you just have to multiply the fronts and the last pieces. You don't have to do the middles. You don't have to do the inside and outside. Just the front and the last. What's I times I? I squared, which is negative 1. And what is 1 times negative 1? Negative 1. I don't have to do the inside outside because those will cancel. Always with the conjugate. That's why we chose the conjugate. So you get negative 3 plus 3i all over negative 2. Now, you can't leave it like that because everything is written in the form of a plus bi. So that will be our real part, and that will be our imaginary part. So what's negative 3 over negative 2? 3 over 2. And then 3i over negative 2 is going to be minus 3 halves I. Anytime you work with a complex number, you must write it in the form of a plus bi. Has to look like that. So 3 halves is my a, negative 3 halves is my b. Does that answer your question? Very good. Okay, last example. What do we multiply the top and bottom by? 5 minus 2i. Let's do the top first. 2 times 5. 2 times negative 2i. Negative 4i. Negative I times 5. And negative I times negative 2i. That'll be a positive 2i squared, which is negative 2. So I'll just erase this and make this a negative 2. So that's my top. Let's look at my bottom. 5 times 5. Do the middles cancel? Yes, that's why we multiplied by the conjugate, to get the middles to cancel. So now you have positive 2i times negative 2i. It's going to be negative 4i squared. What's negative 4i squared? Positive 4. So look at what you got. What's the real part in the top going to be? 8 minus 9i all over 29. You can't leave it like that. You write it as 8 over 29 minus 9 over 29i. Cool. Cindy, wake up. You're never going to learn anything if you sleep through my class. It just isn't going to work out. Oh. Oh, goodness. Okay, so you have an assignment somewhere. I wonder where it went. 11 through 41 odd. That's a total of 16 problems. We did more than 16 in class right now. You have the odds, so you can check your answers in the back of the book. If you simply write down the answers in the back of the book, I will be mad at you, and I will watch your homework assignments like a hawk for the rest of the year, and I will take points off for every single little mistake. So I gave you the odds to help you. I could very easily just assign the evens if you'd rather. Okay, then don't just write the answers down. So do what you're supposed to do. That's what I got for you. I think that's it. I'll try to get the study guide so you can stop back and pick it up by the end of the day. Goodbye, Hannah Kingstrom. If Hannah, you guys know where Hannah is? England. She's getting married. Isn't that what we said yesterday? She's marrying a prince. Let us know how it went, Hannah.